We're going to carry on with our algebra review now, and in this section we're going to talk about some trigonometry and Pythagorean theorem, particularly what you'll be expected to do for this class. Let's start with some basic trig. When we have a right angle triangle and our trigonometry and Pythagorean theorem, I'm going to talk about the right angle triangle. When we have a right angle triangle, the right angle is labeled with a little square. That means this angle is 90 degrees. And then we have to pick an angle and label it theta. I've labeled this one here, but what we're going to talk about, it doesn't matter which one we pick. The ideas are going to be the same. Okay, so I've picked this angle right here. Then when we have our right angle triangle, we have to label the sides. The angle across from the right angle, that's called the hypotenuse, and in shorthand we often just write HYP. The angle next to our angle theta that we've labeled, we call that one adjacent. Adjacent means next to, so that's why we call it that way. That one we label ADJ for adjacent. And last, the side that's opposite the angle, we call that the opposite, and we usually write that OPP. So there's our angle theta, there's our right angle, the hypotenuse, the adjacent, and the opposite. When we talk about trigonometry, we use sine, cosine, and tangent. You probably have a rhyme from high school to help you remember what these are. So when we take the sine of an angle, sine angle is the opposite divided by the hypotenuse. And I'll write it in my shorthand here, OPP over HYP. If you're thinking about units here, typically you're going to see angles in degrees. That means you'll use degrees mode on your calculator. If you get something funky once in a while, your calculator might be in a different setting. That's a good thing to check. The sides of our triangles, they'll often have units, maybe like meters. You'll see that you'll have meters on top, meters on bottom. Those units would cancel, so we're okay there. So sine of an angle is the opposite divided by a hypotenuse. Cosine of an angle theta is the adjacent divided by the hypotenuse. And the tangent of the angle is the opposite divided by the adjacent. These are expressions I'm going to expect you to know off the top of your head. These are things you should know. Okay, so there's our definitions. Why don't we go ahead and do a few little examples now of where we might use this, and then we'll talk about Pythagorean theorem. So let's say we have a triangle that looks like this. There's our right angle, there's our angle theta. I'm saying that theta is 30 degrees, and here's an angle that we've labeled beta. In this question, let's find sine theta, let's find cosine theta, and let's find tan theta, and let's find that angle beta. Okay, when we have this part here, the only piece of information we know is that this angle is 30 degrees and this angle is 90 degrees. So how we're going to find sine theta is just use our calculator. Find your calculator. You probably have a mode button on there somewhere. If it's in degrees mode, somewhere on the display you're going to see a little D. My calculator is in degrees mode, so I can go ahead and use that. So I'm going to say sine 30 degrees equals. Sine of 30 is 0.50. We'd also like to find the cosine of the angle. I'm also going to use my calculator to do that. Cosine 30 degrees, 0.866. If you're doing a whole stack of calculations, you might keep 6 significant figures, or you might keep it in a fraction format. If we're just writing down an answer, you can usually just write down 3 sig figs. We'd also like to find tan of 30 degrees, so tangent of 30 degrees, 0.577. So you'll be finding lots of sines and cosines and tangents of angles. If we want to find our angle beta here, there's an identity about triangles that I expect that you know, and that's all the angles in a triangle have to sum to 180 degrees. So whenever we have any triangle, we know that our angles, which will be theta, plus our right angle is 90, plus beta, they all have to add up to be 180 degrees. This is a thing I expect you'll remember from high school, and you'll have to use this off and on throughout the class. Our angle theta is 30 degrees, so 30 degrees plus 90 degrees plus beta equals 180 degrees. So our angle beta is going to be 180 minus 90 minus 30. You can either do that in your head or do it on the calculator, doesn't matter. 60 degrees. And then just a quick double check, you'll do 60 plus 30 plus 90, yep, that's 180. Okay, so there's something you might have to do during the class. You might have to find sines and cosines, and if you have one angle and a right angle, you might have to figure out the other angle. So that'll be useful for you to be able to do. So now let's come to a right angle triangle. We'll see that this triangle, we've got an angle theta given here, that's 40 degrees. We've got our right angle labeled, we know that's 90. And we've got the length of this side is 2 meters. Notice that this one does have units. For our question here, we're going to ask what is the length of our side here. This one is next to the angle, so I'm going to call that one the adjacent. So what's the length there? And what's the length of this side? What's the length of the opposite? Since this is in meters, we expect these two things to give an answer in meters as well. So here we know the hypotenuse is 2 meters. We know our angle is 40 degrees. We want the opposite and the adjacent. So this leads us to think about using sine and cosine. We know that sine goes with opposite, cosine goes with adjacent. We know the angle and the hypotenuse, so we should be able to figure these things out. Let's start by writing down what is the sine of an angle. So sine of an angle theta is the opposite divided by the hypotenuse. We're trying to solve for the opposite, so we can just cross multiply our hypotenuse up here. So the opposite is going to be the hypotenuse times sine theta. The hypotenuse has a length of 2 meters. We're going to multiply that by the sine of 40 degrees. And what we'll get when we do that, we'll do 2 meters times sine of 40 degrees. We get a length of 1.29 meters. In physics, it's going to be really important to always include units with your answers. Okay, so that's the first thing we wanted. This one is 1.29 meters. Next, we also want the adjacent. We know adjacent goes with cosine, so we'll use cosine next. Cosine theta is adjacent over hypotenuse. We want the adjacent, so we'll cross multiply our hypotenuse. Put in our numbers, 2 meters times cosine 40 degrees. We'll do that on the calculator. And we get 1.53 meters. Okay, so 1.53 meters here. So that's how we can use sine and cosine. When we come to this in class, we'll be doing this exact thing, and we'll do it frequently, especially when we get to our vectors chapter. You'll see when we get to that chapter, rather than label them adjacent and hypotenuse, we're going to label them x and y. So that's a twist you're going to see when we get to class. Let's do another example like this, but not exactly the same. Instead of knowing the hypotenuse in our next example, let's know the length of the opposite. So our sides here, we'll label our sides. This one is the hypotenuse, this one is the opposite, and this one is the adjacent. We know the length of the opposite is 1.25 meters. Let's find the length of the hypotenuse and the length of the adjacent. So we know the opposite. We know that sine is related to the opposite, and sine is also related to the hypotenuse. So let's start with writing down the sine of the angle. Sine theta is opposite divided by hypotenuse. We're trying to find the hypotenuse, so let's start by cross multiplying our hypotenuse up here. So the hypotenuse times sine theta is equal to the opposite. We're almost finished. We want the hypotenuse, so let's divide both sides by sine theta. The hypotenuse is the opposite divided by sine theta. Our opposite is 1.25 meters. I'm going to divide that by sine of 40 degrees. That tells us that our hypotenuse, 1.25 divided by sine 40, our hypotenuse is 1.94 meters. we see that our hypotenuse is longer than this side, and that is an expected result. This one should be longer. Okay, we also want the adjacent. Two ways to find the adjacent now. We know that adjacent goes with cosine. Cosine is adjacent over hypotenuse. And we know that tangent is opposite over adjacent. So we could either use cosine or tangent. Both will work and both will give us the right answer. Why don't we go ahead and use cosine? So cosine theta is equal to adjacent over hypotenuse. Trying to find the adjacent. So the adjacent is going to be the hypotenuse times cosine theta. Our hypotenuse is 1.94 meters. I'm going to multiply that by cosine of 40 degrees. So I don't get any rounding errors. I'm going to keep my hypotenuse from my last step with all the digits in the calculator, and I'm going to multiply that by cosine 40. And I'm going to get 1.49 meters. If you rounded to 1.94, you might get a different digit here. Sometimes we can get a little rounding. So this one is 1.49 meters. Okay, so if we know an angle in any side, we can always find the other two sides using sine, cosine, or tangent, whichever one works for us. Okay, so that's our trigonometry covered. Now let's do our Pythagorean theorem. So let's go back to our triangle. We labeled it originally when we started. There's our theta, there's our 90 degrees. We labeled our sides. Hypotenuse is across from the right angle. Adjacent is next to our angle theta. Opposite is opposite our angle theta. When we talk about Pythagorean theorem, we always have a right angle triangle. Typically, we'll label the hypotenuse with a C and the other two sides A and B. Okay. And Pythagorean theorem says that c squared, the length of the hypotenuse squared, is equal to a squared plus b squared. And there's a proof of this in the appendix of your textbook if you're interested in reading through it. So there's our Pythagorean theorem. It gives us the relationship between the lengths of the three sides. And we're going to use this a lot as well. So let's go ahead and do an example. So in this example, we've got our right angle triangle. We know the lengths of the sides are 2 meters and 1.5 meters. Our right angle is labeled. We've got an angle theta that we don't know. Let's call that theta. And we've got the hypotenuse here that we don't know. Let's give that one a question mark. Let's find C, the hypotenuse, and let's find our angle theta. So we'll use our Pythagorean theorem and our trig to do this. Let's find C first. So Pythagorean theorem says C squared is equal to A squared plus B squared. I'm going to call this side A, this side B. So C squared is going to be 2 meters squared plus 1.5 meters squared. If you're real quick on your calculator, you might do this all in one line. I'll break it into a couple of steps. So 2 squared plus 1.5 squared gives us 6.25. Since we've got our meters squared, the units here are meters squared. So this is c squared. If we want to find c, we have to take the square root of both sides. So the square root of 6.25 meters squared. Hit square root on my calculator and I get 2.5 meters. So c here, our hypotenuse, is 2.5 meters. Quick check, 2.5 is bigger than 2 and 1.5, so we're pretty happy there. We'd also like to find our angle theta. We can go to our trigonometry here. We know the length of each of the three sides, so we could use sine, cosine, or tangent. It doesn't matter. Since I'm given these two sides, I think I'm going to go ahead and use tangent to find my angle. And again, this is something you're going to do quite often, especially when we talk about vectors. So I know that tan theta is opposite over adjacent. So you might remember your rhyme from high school to tell you that. In our picture, we've labeled our opposite with a B and our adjacent with an A. So tan theta is B over A, 1.50 meters divided by 2 meters. 1.5 divided by 2, you can do that in your head, or you can do it on your calculator, doesn't really matter which. 1.5 divided by 2, we get 0.75. If you're thinking about units, you see there's a meters on top, meters on the bottom, so they cancel. We don't have any units left here. If we'd like to find the angle theta, we have to get rid of the tan bit. The way we get rid of the tan bit is we do the inverse tan of both sides. The inverse tan of a tan leaves us with theta. So then we have to do the inverse tan. We write that as tan to the minus 1 of 0.75. So on my calculator, I do shift tan of 0.75. That gives me an angle theta of 36.9 degrees. So my angle theta here, 36.9 degrees. So this is something we'll be doing lots and lots of, so you'll see lots of practice of this. One last example now of our Pythagorean theorem. So again, we've got a triangle. Our right angle is labeled. Our angle theta is unknown. This time we've got our hypotenuse given. So that's C, 3.25 meters. Our opposite is given. We can call that one B. And we don't know the adjacent. Let's try and find the adjacent, and let's try and find theta. Let's apply Pythagorean theorem to find A. Let's be really careful here when we do this. We know C squared is A squared plus B squared. We want A squared, so we have to subtract B squared from both sides. A squared is C squared minus B squared. You've got to be really careful when you're bringing things to other sides. If you didn't get a minus here, you'd end up with a funny answer. So A squared is going to be 3.25 meters squared. Subtract 2.5 meters squared. Again, you can all do this in one line in your calculator, or you can do it in steps. I'll go through it with steps just because we're trying to show all the details here. 4.3125 meters squared. Because we squared our two terms here, we've got our meters squared. To get our A, we have to do the square root of both sides. So I'll do square root answer in my calculator, and I get 2.08 meters. So down here, my adjacent is 2.08 meters. This number is smaller than my hypotenuse, so we're okay with this answer. All right, next we'd like to find our angle theta. I see that the numbers I'm given are the opposite and the hypotenuse. Since I'm given those numbers, I'd like to use the given numbers. Opposite and hypotenuse go with sine, so I'm going to use sine to solve this problem. Sine theta is opposite over hypotenuse. My opposite I've labeled B, my hypotenuse I've labeled C. 2.50 meters divided by 3.25 meters. So you can do that in your head or on your calculator, it doesn't matter which. So sine theta is equal to 0.769. Meters and meters cancel out here, so no units down here. To find my theta, just like we did on the last slide, I want to get rid of my sine. To do that, I have to do the inverse sine of both sides. So my angle theta, just so I can keep all the digits in my calculator, I'm going to do this one in my calculator. I do inverse sine, so there's my inverse sine. Then I'm going to hit the answer button, and I get 50.3 degrees. Okay, so that takes us pretty carefully through the Pythagorean theorem and the trig that you're going to be seeing a lot of in this course.